Good morning, teacher. Now, today we will solve chapter 5.3 of arithmetic progression. And because we will solve some questions, mostly questions we have been already solved in the class of chapter 5.2. Now, today we are going to solve the question of 5.3. So, I am taking some questions. I have already told you that the formula of sum of the sum formula is already told you. I have already told you this sum formula. So now the questions are related to this formula in chapter 5.3. So let's start. Question number 1 from your book. Find the sum of the AP. And AP is given here. AP 2712. 10 terms. So, this position you are looking there in this question, you are looking here. You have A is equal to 2, B is equal to A2 minus A1, which means that 7 minus 2 is equal to 5. And AN is equal to 10. It is already given here. So, which means that n last two n is this n total terms are given. Which means that n is equal to 10 is given. So use the formula, sum formula. Sn is equal to n by 2 2a plus n minus 1 into d. Just put the value. N is equal to 10 is given. In this position, you have to be here. An AP is given to 7 terms, and total terms, which means that n is equal to 10 given here. Total terms are 10. So n is equal to 10 given, and a is equal to this, and b is equal to a2 minus a1 equal to 5. So just put the value 2 into 2 plus 11 minus 1. Not 11, only 10. And d is equal to 5. So n is equal to 10, a is equal to 2, and d equal to 5. Now solve this. This implies that 5 कट जाएगा. So it is 5. Now 4 plus 9 into 5 is equal to 5. This one 4 plus 35 is equal to 5 multiplied by 49. So as n is equal to 5 into 39. So x is equal to 245. Which means that when this formula you will use when you know the n is equal to how much. When n is given, then you will use this formula. Otherwise, first of all, you have to find the value of n, then you will use this formula. Now, when n is not given here. So, let's see the question number 2. Let's see. It is given here. Question number 2 is given here. find the sum seven plus 10 whole 1 upon 2 plus 14 plus 84. So let's see. In this arithmetic progression, you want to find the sum of this arithmetic progression, and here you have a and the last en is 84. But you don't know how many terms are between the 7 and 84. The simple thing is just try to count or use the formula and find out the value of n, which means that how many terms, total terms contains in this AP. So in this situation you have A is equal to 7. Now D is equal to A2 minus A1. So this implies that your AP is 10 whole 1 upon 2 minus 7. This means that we have just obtained. Now you have given here n is equal to 84. The last term is given here 84. So find n. It is the formula. It is also formula. If an is known and you want to find the value of n, then you can easily find the value of n by putting the value of a and d in this formula. You will get n. In this arithmetic progression, you have total terms, the first term, second term, and the last term. N. It is given here, but you don't know how many terms are present in this arithmetic progression. So first of all, you have to find the value of n, because when you will get the value of n, then you will put the value of n in this formula, in this section, to find the sum of the arithmetic progression. So because in this position you don't know what is the value of n, how many terms are present in this arithmetic progression. So by using the formula of arithmetic progression, an is equal to a plus n minus 1 into b, you will get the number of terms. So a is given 7, d is a2 minus a1, which means that we have find here counted 7 by 2. After solving this, we are getting 7 by 2. This is your d. Now put the value of d by now use this formula to find the value of n. Just removing some part of the question. N is given 84. An is equal to 84. So just simple put the value of 84. Now a is given here 7 plus n minus 1 into d is given 7 by 2. So just solve it. N minus 1 into 7 by 2 is equal to 84 minus 7. When you will transpose 7 in this in the left hand side, it will be negative. So just 7 by 7. So n minus 1 into 7 by 2 is equal to 77. I am removing this part also. So just Now this implies that n minus 1 is equal to 77 multiplied by 2 upon 7. Clear? This 2 will be multiplied, cross multiplied, 77 into 2, and since this 7 is in the in multiplication, then after transformation it will be in the division. So just take 11, so n minus 1 is equal to 32. So this implies that n is equal to 22 plus 1 is equal to 23. Now you have all those things whatever you want to use in the sum formula. Sn is equal to n by 2 into 2a plus n minus 1 into b. Clear? So now put all these values in the formula. Now you have n is equal to 23. So I want to tell one more formula. If you have such kind, then you can also use, because the value of n minus 1 into t equal to l. That is called the last term of arithmetic progression. So you can use this formula also. So the sum Sn is equal to a is equal to n is equal to, you have found n is equal to 23. Just you have found, so n is equal to 23 upon 2. Now put a is equal to 7 and plus l. L is not the last term. So the last term is 84. It is given in the question. So Sn is equal to 23 upon 2, 91. Now Sn is equal to, just multiply 23 and 91 divided by 2. Whatever the value you will get, that will be the required result. That will be the sum of the arithmetic progression. Now I am telling the summary of this question. It was given here. It was your arithmetic progression. Just I am summarizing this. It was your arithmetic progression, and you want to find the sum of the given arithmetic progression. So in this section you are looking here, a is given and d you have found 7 by 2 by subtracting a2 minus a1. It was the value of d, and after solving a2 minus a1 you found 7 by 2. This was the d. But you don't know how many terms are present in this series, in this arithmetic progression. You don't know how many terms are present, but you have only the last term, that is 84. An is given here 84, and you don't know how many terms are present. So you will found the value of n, because if you want to find the sum of the series, you must have the value of n, because in this formula n by 2 into 2a plus n minus 1 into d. So when n is unknown, then first of all you will get the value of n. So we found the value of n by using the formula a n is equal to a plus n minus 1 into d. This we have found it. So when we have put the value of an, that is which is 84 in this formula, we found the value of n is equal to 23. Now after solving this equation we are getting 23. So when we have 20 n, the value of n, value of a, value of d, all those things whatever the formula wants we have. Now put all the values. Now n is equal to 23, a is equal to 7 and d is equal to 7 by 2 and n is equal to 23. After solving this we are getting whatever will be the multiplication of this and division. After multiplication you will do the division, whatever value you will get, that will be the required sum. Now again let's see some another question. Now the question number 3, in an arithmetic progression you have given what you have: a is equal to 5, d is equal to 3, an is equal to 50, then find n and sn. Then what will be the answer? The same what we have done in the question number second, just we will do. Since an is equal to a plus n minus 1 into d, then put the value of an, that is n is equal to 50 plus a is equal to 5 plus n minus 1 and d is given here 3. So in this position just transpose it: n minus 1 into 3 is equal to 50 minus 5. So n minus 1 into 3 is equal to 45. So n minus 1 is equal to 45 upon 3, which is equal to 15. So n minus 1 is equal to 15. So n is equal to 15 plus 1. Therefore n is equal to 16. So this is your required value of n. You have found this n. Now you want to find the value of Sn. Sn is equal to n by 2, 2a plus n minus 1 into d. Now put all the values, whatever you have found here. It is already given, a is mentioned here, 5, d is given 3, and n you have found, that is 16. So you will put here the value of n is 16, a is equal to 5, n equal to 16, and d equal to 3. Then after putting all the values, whatever you will get, that will be the sum of the series. Now let's see another question. So let's take another question. That is question number 4. How many terms of the arithmetic progression, that is AP arithmetic progression, 9, 17, 25 must be taken to give a sum of 636. Now, look here. In this series, you have what you have? How many terms of the AP? 9, 17, 25 must be taken to give the sum 3 versus 6, 36. Which means that you have an arithmetic progression. You have the sum of total arithmetic progression, but you don't know how many terms are present in the an arithmetic progression. So first of all, you will find the total number of terms, that is n. You will find the value of n. So how will you get? Now you have a is equal to 9, d is equal to a2 minus a1, that is 17 minus 9 is equal to 8, and Sn is equal to given here 636. These three things you have. Now put the value in the formula. Sn is equal to n by 2 2a plus n minus 1 into d. So Sn you have 636. 636. It is given because in this series you are looking here how many terms of the arithmetic progression this must be taken to give the sum of 636. You have an arithmetic progression and you have the total sum of the arithmetic progression, but you don't have the number of terms. So you want to find the number of terms whose sums are equal to 636. The total number of terms, when the total number of terms will be added, then you will get the result in this series. So now let's see, put n by 2. You don't know what is the value of n. Now 2 into 9 plus n is unknown and d is given here. Just solve it. Now I am erasing some part of the question to find the value. Six 36 is equal to n by 2 So that is 5n, 4n. So 4n square plus 5n minus 3. Now you have the quadratic equation. Clear? So you have after now again I am summarizing this. Listen carefully. This is your arithmetic progression. You have the total sum 636. It is your total sum of the total terms, whatever are present in this arithmetic progression is given here. The total sum is given 636, and but in this situation you don't know how many terms are present in this series. But the total sum is given 636. Now put those values, whatever present in the question, in this formula, because this is your sum formula. This is your sum formula. Clear? And you have Sn is equal to 636, but you don't know how many terms are present. So just left the value of n and put the value of a from the equation, from the series sequence. So a is equal to 2 into 9 and plus n is unknown and b you found here. Clear? So after solving this equation, you are getting an quadratic equation which is 4n square plus 5n minus 6 Clear? Now what you will do, since this is an quadratic equation, so you know that it is a second degree polynomial, so you know that it will provide at least two solutions. So find out the solution by using the two methods. You can use two methods, that is, one is quadratic formula and another is to break the middle term. So now I am using the method of to break the middle term. If you are unable to break the middle term, so you can easily use the value of quadratic equation. You can put all the values in the quadratic equation, so you will get the easy solution. Now it is your 4n square plus 5n minus 636 is equal to 0. It is your quadratic equation. So you have two choices. One is quadratic formula, that is minus b plus minus under root b square minus 4ac upon 2a. This is more easy than to break the middle term. If you can break the middle term, then you can use the simply method of to break middle term breaking. Or if you are unable to break the middle term, then you can use this formula. It depends on your choice. Now I am using the method of to breaking the middle term. So how you will do? I have already told you that if any equation is given in the form of ax square plus bx plus c, then first of all, to break the middle term, what you will do? You will multiply the constant c will be multiplied the coefficient of x square. That is, you will get the value ac, and you will find the find possible factors of this AC, and after that, rearranging those factors, you will get the value of Bx, which means that if you are adding or subtracting the two terms, then you must have the value of bx, and if you are multiplying both terms, then you must have the value of ac. Clear? So when you will multiply by this, whatever you will get, now I am doing directly. Clear? Now solve it. Now you are looking here, n is common in both. So n, when you are taking out n, then you are getting here 4n plus 53. Now when you are taking out negative 12, then you are getting here 4n minus 53 is equal to 0. Then n minus 12, n minus 12 and 4n plus 50 is equal to 0. So when 4n plus 53 is equal to 0, then 4n is equal to minus 53, then n is equal to minus 53 upon 4. Now reject the negative value. Now reject the negative value. Because in this situation, in the question you are looking, the total sum is given 636. Sorry, it is your sum. It was given here. It is positive, and any term is not negative given in the series because it was started 9, 17, 25, and so on. It was your arithmetic progression, and this arithmetic progression is given here. All numbers are positive, and the total sum is also given here positive. So just ignore this negative result. Clear? Because series is total positive. So, and the mean difference, the common difference is also positive. So sum is total positive here, common difference is positive here, and the number of terms what are present in this arithmetic progression is total positive. So the value of n may never be negative or in this format. So just ignore this. Now consider n minus 12 is equal to 0. So n is equal to positive 12. So this is the required result, which means that the number of terms which are present in arithmetic progression, that is 9, 17, 25 up to so on, is given here, and the total sum is 636. So the number of terms are 12, and the total sum of the number of terms in this series, which means the total 12 numbers sum according to the series, the total sum will be 636. This is your required result. Now let's see another question. Take another question. Question number 5. The first term of an AP is 5. Last term is 45 and sum is 400. Find the number of terms. Find the number of terms and common difference. So solution: a equal to 5 given, an is equal to 45 given, Sn is equal to 400. So what you will do? Just you will use the simple formula. Sn is equal to n by 2 into a plus am. Here, so to find the way, but you will use this simple formula. But in this condition, you don't have n. So what you will do? You will find an is equal to a plus n minus 1 into d. So when you will put the value of am, that is given 45, a is given here, that is in this formula. When you will put the value of an is equal to 45, that is this 45, and a is equal to 5 plus n minus 1 and the common difference d. Here, so when you will solve this, you will get the n minus 1 into d. So clear? Or another thing is, just put the value here. An is equal to 45, a is equal to this, and s is equal to 400. A is equal to 5 and this is 45. Now solve it, you will get the value of n. After solving this, you will get the value of n. And when you will put the value of n in this formula, then you will get n minus 1 into d, then you will get the value of d. Here, to find the n, you will solve this equation. You will first of all, you will put all the value of a and n is given here 45, a is given 5. When you will put the value of a and a, then you will get the value of n after solving this. After that, when you will get n, then you will put the value n in this section, then you will get this value of d. Clear? So this is all about for today. So thank you, students.